Tutorial over 4/6, the quadratic formula and the discriminant. Your new vocabulary is quadratic formula and discriminant. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where a, b, and c are the coefficients on your quadratic formula. So we have our standard form, which is ax squared plus bx plus c equals 0. And the a, b, and c we're talking about are the coefficients in front of your x values. Okay? If you would like a proof of this formula, there's one at the beginning of the book. The discriminant, which is represented by b squared minus 4ac. Towards the end of this video, you will actually learn if this is a positive, a negative, or if it's equal to 0, how many different roots your quadratic formula will have. So, we have the quadratic formula, which is what we wrote on the last page. An example is, if we look at our quadratic equation, this is in the form of ax squared plus bx plus c equals 0. In this case, there's a 1 in front of the x squared, so a is equal to 1. There's a 5 in front of our x value, so b is equal to 5. And the number by itself is 6, so c equals 6. Then all you do is plug in accordingly where you see the different letters. Alright, so example 1, solve x squared minus 8x equals 33 by using the quadratic formula. Before we can use the quadratic formula, we have to get everything to one side of the equal sign. So what I'm going to do is I'm going to subtract 33 from both sides, and that's going to give me x squared minus 8x minus 33 equals 0. Now I have what I need to set up. I need to identify a, b, and c, so a is going to be in front of my x squared term, b is in front of x, and c is the number by itself. So I know that a is 1, b is negative 8, c is negative 33, and I need to plug in accordingly to the quadratic formula. This you should have memorized. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, now we're going to plug and chug. Negative b, which is the opposite of what b actually is, so instead of this being a negative 8, this is going to turn into a positive 8, plus or minus the square root of, parentheses, negative 8 squared, minus 4, a is 1, c is negative 33, all over 2 times 1. Alright, now we need to simplify. We're going to start with the stuff underneath the square root. We know that negative 8 squared is 64, so we have 8 plus or minus the square root of 64. 4 times 1 is 4. 4 times negative 33 is 132. So we have a negative times a negative, that gives us a positive, so we're going to add 132 all over 2. We're still going to simplify the stuff on the inside of the radical. So 64 plus 130 is 196. So we have 8 plus or minus the square root of 196. And that should be going off in your head because 196 is a perfect square. So the square root of 196 is 14. So we have 8 plus or minus 14 divided by 2. Now I'm going to erase some stuff so we can rewrite this. Now, we have to set this up as 2 different roots. We have 8 plus 14 divided by 2, and then we have 8 minus 14 divided by 2. On the first one, we have 22 divided by 2, which is 11. And over here, we have 8 minus 14, which is negative 6, divided by 2, which is negative 3. So we have x equals 11 or negative 3. Now before you can say those are your actual answers, you need to plug them in and check. And real quick, if we do 11 squared, that's 121 minus 8 times 11, which is 88. That does indeed equal 33. And if we plugged in negative 3 squared is 9. 9 minus 8 times negative 3, so 9 plus 24 is 33. So these two do work. Example 2, it says solve x squared minus 34x plus 289 equals 0 by using the quadratic formula. So we know that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. We have to first identify what a is. A is equal to 1 because there's a 1 in front of our x squared. We know that b is equal to negative 34 because that's what's in front of my x term. And we know that c is equal to 289 because that's the number by itself. Now I'm going to plug in accordingly. We have negative b, so meaning the opposite sign of b, so we're going to have 34 plus or minus the square root, parentheses negative 34 squared, minus 4 times 1 times 289 divided by 2 times 1. All I did was take these coefficients and plug them into my quadratic formula. That's where all these numbers came from. Alright, so now we're going to simplify. When you're simplifying, you always want to start with the stuff that's underneath the square root. We get 34 plus or minus the square root of 1,156 minus, well, if you do 4 times 289, that's 1,156. All divided by 2, because 2 times 1 is 2. Well, 1,156 minus 1,156 is 0, so we have 34 plus or minus the square root of 0 divided by 2. Well, the square root of 0 is just 0, so we have 34 divided by 2. This kind of cancels out. And we have 34 divided by 2, which is 17. So in this case, we only have one rational root, x equals 17. Example 3, solve x squared minus 6x plus 2 equals 0 by using the quadratic formula. So again, we need our quadratic formula, which is negative b plus or minus b squared minus 4ac divided by 2a. We need to identify a, b, and c. A is in front of my x squared term, which is 1. B is in front of my x squared term, my x term, which is negative 6. And c is 2. Now we're going to plug in accordingly. We're going to have negative 6, so 6 plus or minus the square root, negative 6 squared. Always make sure you put your parentheses, because that'll mess you up if you don't. Minus 4 times 1 times 2, all divided by 2 times 1. Always start with what's underneath your radical. So we are going to take negative 6 squared, which is 36. So 6 plus or minus the square root of 36. 4 times 1 times 2 is 8. So 36 minus 8 divided by 2. Then we're going to take 36 minus 8. We get 6 plus or minus the square root of 28 divided by 2. So we need to actually simplify the 28. Remember, you can do this by your tree. We have 2 and 14, 2 and 7. 2's are partners. 1's going to die, 1's going to break out, so we have 2 square roots of 7. So we can rewrite this as 6 plus or minus 2 square roots of 7 divided by 2. And now we can rewrite this as 6 plus 2 square roots of 7 divided by 2, or 2 minus 2 square roots of 7 divided by 2. The plus or minus allows you to have two different answers, and you must set them up as two different roots. Example 4, solve x squared plus 13 equals 6x by using the quadratic formula. In order for us to use the quadratic formula, we must put this in order, and we need to have everything to one side of the equal sign. So we must subtract 6x from both sides. I'm going to rearrange this as x squared minus 6x plus 13 equals 0. From here, we can actually plug into the quadratic formula. We know that a is equal to 1 because it's in front of my x squared term, b is equal to negative 6, and c is equal to 13. Now we're going to plug in negative b, which is going to give me 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13 divided by 2a. Oops, 2 times 1 in this case. And now we're going to simplify. Whatever's underneath the radical goes first. 6 plus or minus the square root of 36, 4 times 13, which is 52. So 36 minus 52 divided by 2. Now, when you actually take 36 minus 52, you're going to get a negative answer. And that's going to give you 6 plus or minus the square root of negative 16 divided by 2. Now, remember, when we're dealing with negative numbers underneath the radical, we have to pull that out, and it has to be an I. So the square root of negative 16 is actually 4i. So we have 6 plus or minus 4i divided by 2. Now we can simplify further. If you see that you have a factor of 2 in the first number and the second, that's a condition. It has to be a factor of both of these numbers. You cannot just divide by 2 into 6, and you cannot just divide by 2 into 4. So if all three of these numbers have the same factor, you can factor that out. So we take 6 divided by 2, and that gives you a 3. 4 divided by 2 is 2. And then, of course, 2 divided by 2 is 1, so you don't have to write that. So this is 3, this is 2, and this actually becomes our answer. X equals 3 plus or minus 2i. You can rewrite this as 3 plus 2i or 3 minus 2i. That will be the correct answer as well. This brings us to the discriminant. Notice how in all of those questions, we always had to simplify everything underneath the radical first before we could do anything. So b squared minus 4ac had some really good properties. If it ends up being a perfect square, it's going to give you 2 real roots. That means there's 2 places where the quadratic actually crosses on the x-axis. If you get b squared minus 4ac greater than 0, and it's not a perfect square, it means you're going to have 2 real irrational roots. They're still going to cross the x-axis, but they might not land on pretty points. If b squared minus 4ac is actually equal to 0, you have 1 rational root. That means it's just barely going to touch the x-axis. And if you have anything underneath the radical, so b squared minus 4ac, and it's a negative number, it's going to be 2 complex roots, meaning it never actually crosses the x-axis. They're going to be imaginary numbers. So with that logic, let's try example 5. It says find the value of the discriminant for x squared plus 3x plus 5 equals 0. Then describe the number and type of roots for the equation. Well, for the discriminant, we don't need the whole quadratic formula. We just need b squared minus 4ac. If we look at our question, we know that a is equal to 1 because x squared has a 1 in front of it. B is equal to 3 because that's in front of my x term, and C is equal to 5, and that's what number is by itself. So I'm going to plug in accordingly. B is 3, so I get 3 squared minus 4 times A is 1 times C is 5. 3 squared is 9, minus 4 times 1 times 5 is 20. 9 minus 20 is negative 11. Since we got a negative number, that means that for the discriminant, that means there's two complex roots. That means they're going to be imaginary. And you can always refer to the chart that we just looked at. Second part of this problem, it says find the value of the discriminant for x squared minus 11x plus 10 equals 0. Then describe the number and the type of roots for the equation. So again, the discriminant is b squared minus 4ac. We know that a is equal to 1 because that's in front of your x squared term. B is equal to negative 11, that's in front of your x term, and C is equal to 10. That's the number by itself. Now let's plug in it accordingly. We have negative 11 squared minus 4 times 1 times 10. 11 squared is 121 minus 40. 121 minus 40 is 81. Now, this should be screaming at you. 81 is a perfect square because the square root of it is 9. The square root is a whole number. So since it is a perfect square, that means we're going to have two real rational roots. Last thing we're going to talk about is the different methods for solving quadratic equations and when is the best time to use them. You can solve them by graphing, factoring, square root property, completing the square, and the quadratic formula. The first three, you can sometimes use them depending on when the conditions are. Completing the square and the quadratic formula, no matter what quadratic you get, you can always use these. Okay, and here are some examples of when would be the best time to use each method. Thanks for watching.